Jó reggelt kívánok mindenkinek, köszöntök mindenkit az Online Akadémia mai adásán, ahol is a napenergia távhő célú hasznosításairól fogunk hallani. Az előadás angol nyelvű lesz, úgyhogy remélem ez nem okoz túl nagy gondot senkinek. Későbbiekben, miután felvesszük, majd egy magyar feliratot készítünk hozzá természetesen. So good morning, Florent. I'd like to ask you to start the presentation. I think there is going to be a bit more people coming. I will let them in, but as we will record the presentation, it will be possible to view it afterwards as well. So Florent, the floor is yours.
Super. Thank you. Good morning, everybody. Thank you, David. Thank you for the invitation and the opportunity to present to you today an interesting topic about solar thermal for district heating. My name is Florent. I'm sorry about my Hungarian is in existence, so we have to do it in English today. Yeah, my name is Florent. I'm technical account manager for TVP Solar, the Swiss company manufacturer of a solar thermal panel for district heating application. And today we will talk about unlocking the potential of solar thermal for district heating. So let me share my screen. Here we go. Do you see my screen?
Yes, perfect.
Super. Yeah, so basically the picture you can see here will illustrate what we're going to talk about this morning. Let's start from the beginning by the sun. The sun is, as you all may know, a general source of energy. There is a lot of energy going on the surface of the Earth every day, and not only in the higher radiance places, but basically we know now we have technologies to harvest this sunny radiance, whatever the region and whatever the irradiance we have at location. There are two big types to harvest the sun, to harvest the energy from the sun. One is the solar photovoltaic, so the one you see on the left side, to generate electricity. The other is the solar heat, so basically producing heat from the sun, either to produce electricity, and it won't be the topic of today because our topic is producing heat for district heating network. So solar heat can either produce electricity, can also, of course, produce hot water or steam, and that will be our main topic of today. We will go a little bit more in details on the different categories of technologies, the concentrated one, the non-concentrated one, but we will stick basically to producing heat from solar heat technologies. A few words about Solar Heat Europe, because I'm also talking today not exclusively under my TVP Solar flag, but also from Solar Heat Europe, which TVP Solar is member of. It's the association, basically the European Association for Solar Thermal in Europe. There are basically lots of manufacturers, but also engineering companies, institutions that are part of this association, and it brings a lot of materials and also support when having any kind of questions regarding solar thermal for district heating, but also more generally solar thermal for residential application and also industrial application. So this association is having some meetings, also providing some materials, and you're always welcome to contact Solar Heat Europe Association whenever you have any questions on related to solar thermal. Also, something that is interesting about solar thermal is the fact that most of the manufacturers are in the EU. So when you are basically making a solar thermal project, you are benefiting directly the EU, and that's even more important now. You know, talking about sovereignty, talking about the reindustrialization of EU. Unfortunately, PV was the photovoltaic was invented in Europe, but then it quickly, you know, went out of Europe for his manufacturing. We have a chance here to have technologies that are being created in Europe and are still manufactured in Europe. Different type of collectors in different countries all have its own advantages and applications. Now let's go to the solar heat and the different type of collectors. So here you have a scale that is the temperature. Of course, you all know how important is the temperature for district heating networks. So the scale here goes from 40 degrees Celsius to 400 degrees Celsius. Initially, you know, solar thermal was like the one we see here, so a normal flat plate installed on the house for residential application to do basically the shower, the hot shower, or the hot water, the sanitary hot water of the building. So that's really how solar thermal started, and with time, different technologies appeared for different usage as well. We can talk about the evacuated tubes that is using basically the vacuum to insulate the panel. We all know that vacuum is one of the best insulator you can find on Earth, and we have two main type of technologies. The one that are stationary, so it means that they are fixed to a support or to a roof, and they do not move. And they are non-concentrated technology. It means that basically they do not concentrate the light, so they capture both the direct and the diffuse light. This is really important because especially in Europe and especially in Hungary as well, because we have a lot of diffuse light in Europe. Yesterday, when I was preparing this presentation, I've checked the meteo, the weather data, the meteo data statistics over the last year, and basically Budapest is almost the same irradiance and same meteo data that we have here in Geneva. I'm based in Geneva. There is a lot of diffuse light, so about 50% of the light is refracted through the clouds, and not harvesting this diffuse light is, of course, a loss and less energy output in the end. So stationary, non-concentrating technologies, and on the other side, also on the other side of the temperature scale, you have technologies that are concentrated. So basically they use mirrors. The mirrors are concentrating the lights over a tubes where the water is flowing, and these technologies only capture the direct light, so they will mainly be used in high irradiance places next to the equator. Basically, that's where they're gonna be the most efficient, and they have to track the sun, so they have basically a tracking system that will make the mirror move towards the sun to maximize the harvesting of the energy. So that was the picture basically in the last 20 years, and then there is another technology that I want to talk to you about today, is the high vacuum flat plate, that is a little bit in the middle of the, let's say, the residential technologies that are also used for district heating networks, because they can provide heat up to 80 degrees Celsius. And in the middle of these residential and let's say low temperature technologies and the really high temperature concentrating technologies that are more to do high temperature, there is a high vacuum flat plate that has a range of temperature between, let's say, 60 degrees Celsius to 180 degrees Celsius, designed for basically the district heating applications and also industrial applications that are requiring higher temperature. We all know that district heating networks in Europe are requiring, let's say, sometimes the return temperature can be up to 70 degrees Celsius. And usually the supply line is around between 70 to 90 degrees Celsius. So it requires pretty high temperature for traditional solar technologies. And this is where basically the high vacuum flat plate can have his advantage. Something I wanted also to focus on is the solar key mark. This is the European certification scheme for solar thermal. It is important because basically it exists more than 650 different brands and different collectors, different technologies, solar thermal technologies. So how to basically compare one to each other, how to know if one is performant for the application you are looking for and for your network that requires specific temperatures and work in specific conditions. Also, what about the lifetime of the product, and what about its robustness towards hail or robustness over time? That's why the solar key mark was created. It was to certify via third-party certifier a solar thermal collector to give basically two main information: one on the performance, and the other one on the quality and the robustness of the collector of the technology. So typically, the solar key mark database is available. Tomorrow, you want to compare two different technologies, you can go on this database. I've just put it here, the link. You look for the brand and the collector, and you can rapidly on the second page of the certificate, you can rapidly look at the performance in different locations at different temperatures. Typically, the one that will be let's say the most illustrative for Europe and especially for Hungary is the Würzburg at 75 degrees Celsius, because this is the one that has Würzburg is a city in Germany that has an irradiance that is really close to the one you have in Hungary, and the 75 degrees Celsius is usually the temperatures you're looking for your network. So this figure here, this number gives you the annual output per square meter area, and you can have this number for any collectors that is solar key mark certified to make some comparison. And there is also on top of this all the let's say the quality insurance that the solar key mark provides. So that's something interesting when developing a project, looking at different technologies. You can have a look to the performance and take something that really makes sense for your application. Now let's go back a little bit on how solar thermal works in the end, because most of the people they really know how photovoltaics work with these semiconductors and the electrons that you will create from the sun. Solar thermal is sometimes a little bit in the shadow of the photovoltaic, but the way it works is fairly simple. So I have this small invitation. Whoop. just cut the sound. So super easy. You have a closed loop on the solar field size, and you have an heat exchanger that is making the transfer of the heat to an energy storage or to the application, basically. So here on this picture, it's an energy storage, but you can imagine, of course, having this energy storage that is connected to a district heating network, either in parallel or in series. So you have a pump on the solar field size. When it's the night, basically nothing is moving. So the water glycol is not circulating. You have no irradiance, no sun available. So the water is cold. That's why it's blue, and nothing is happening. At the minute you have the sun rising, the water will start to hit in the solar collector, and then at the moment the temperature that is reached inside the solar field loop is achieving the supply temperature, the application temperature, the target temperature, then the pump here will start to flow, and the exchange will start to happen between the solar field, the solar thermal field, and the application that could be energy storage, or here we see different type of application, as we said, the sanitary hot water, space heating, process heat, even cooling, and of course part of this application can be the district heating network. So this is really illustrative and on a small scale. How it works when you have a district heating network. So usually you don't want to have your district heating networks only relying on solar thermal. Solar thermal will never be a standalone solution to decarbonize your district heating network. It will always be part of the solution and part of a wider combination of different heat sources. So this picture here, you can see a typical integration of a solar thermal field. The collector field is here. You have a short-term heat storage. So this is purely a stratified tank, big tank in steel, where you feed the hot water inside. It's stratified, and it can be really useful to harvest at best during daytime the solar thermal, the heat, basically the solar heat, to harvest it during daytime and keeping it for the high demand time, like in the night or early morning. I mean, in the evening or early morning. So that's a short-term storage that will be there to manage the desynchronization between when the sun is harvested and when the heat is really needed into the district heating network. And connected to this same network, you will have, of course, other sources like a biomass boiler, cogeneration plant, a gas boiler, or heat pump. The solar field can be either centralized, so next to the heating center, or decentralized on the network, and then act more as a booster of temperature. Like you can imagine having a district heating networks of tens of kilometers. Sometimes it requires to heat up again the temperature at the end of the network. So having a solar thermal field decentralized can also be a solution. The goal, of course, is that the temperature you're gonna provide to the storage is the one matching the need of the network. So there are different way of connecting. Can be either taking the return temperature from the network and heating the supply temperature. You can also imagine being as a preheating solution where you take the return temperature from the network and you preheat the return before it enters into the heating center with the other sources of energy that can then brings the heat to the right temperature. So this is as I was already explaining just before, solar thermal can be combined with all type of energy sources. Of course, solar thermal will have most of its production during summertime. So usually the design that is made when integrating to a district heating network is to go and be as close as possible to the 100% coverage by solar during the summer months, so like June, July, and August. That's the maximum you could imagine for design. If you want to go further, then it won't be only short-term storage, but it could be seasonal storage attached to your solar thermal field. And then you can imagine storing a big quantity of heat during the summertime to then reuse it during autumn or winter time. There is two projects under development in Europe using the combination between solar thermal and seasonal storage. One is in Kosovo, in Pristina, and the second one is in Novi Sad in Serbia. So both will not only cover the summer, but will also cover extended months after the summertime, thanks to the seasonal storage, plus a heat pump to bring again the temperature up to the level required by the network. Otherwise, of course, any other sources can be combined to the solar thermal, the fossil fuels, geothermal, biomass, biogas, all kind of compatibility here is feasible. And typically, I will give you an example in Switzerland. Switzerland, about 80% of the district heating networks are running on biomass, but there is really a big question now in Switzerland about the wood resources. Is it sustainable to in the long term to shift all these district heating networks to biomass? Solar thermal can bring an advantage here to work with solar during the summer and save the wood resources for the winter, where of course solar thermal will be less efficient. So that's a way to basically use the right source at the right period in the year, taking advantage of the sources of energy that are available at each period of the year. Now, solar thermal for district heating is not let's say a fancy innovation, but has been widely already installed in Europe. So you can see here a few statistics. There is 250 towns and cities in Europe that use solar heat already. It's representing more than 1.3 gigawatt of peak power. And the champion in solar thermal was Denmark. And now it's follow closely, and also there is a big dynamic in Germany with already 56 district heating existing. So many references basically are already installed and in operation for many years. So there are out there all the actors, all the experts and also all the references available to basically make a project that makes sense and that will always also be custom to your district heating network. Each district heating network has its own parameters, has its own specificities, so each project will be different, and basically you have more than 256 references to help you find the right solution, and you are also the expert that are available to support you in finding the best solution for your network. Now I will say a few words about two references that I've selected. This one is a new one, is one that was done in collaboration with a company called Novar, and for which TVP Solar has basically supplied the panels and made the installation. So it was the contractor for this installation. It uses this new solution we're proposing. It's the high vacuum technology. Why high vacuum technology is interesting for district heating network is because of this range of temperature. So everything between 60 to 180 degrees Celsius. So basically, when you are using a high vacuum flat plate for your district heating network, you're gonna use it at the low end of its range of temperature, maximizing the efficiency of the system. This installation is in the north of the Netherlands. So sometimes, you know, when people are asking me, but you're sure about the efficiency of using a solar technology in Europe? I told them that our biggest installation up to date for TVP Solar is this 37 megawatt project in the northern of the Netherlands, where the sun is pretty poor, low irradiance, just below 1,000 kilowatt hours per square meter per year. To give you a comparison, in Budapest you have 1,230. So you have 20% more sun in Budapest that you have in Dokwerk, in this north of the Netherlands. The first heat was produced in December 2024, so it's really a brand new installation, and it's 48,000 square meters of panels installed on 10 hectares of land and associated to a short-term storage of 6,000 cubic meters. So it's the tank you see here. So you see basically on this picture all the different components of a solar thermal plant, the solar field, of course. Usually you have a storage tank, and then you have the thermal room here that has inside all the what we call the thermal block, the solar substation with the pumps and the control systems, all the equipment basically to run and circulate the water inside the solar field. The production expected for this installation will be about 25 gigawatt hours per year. So that represents 520 kilowatt hours per square meter per year. When I talk here square meters, I'm talking square meters of panels. And the delivery temperature here will be 85 degrees Celsius with a return temperature of 69 degrees Celsius. So pretty high return temperature. Low irradiance, but still the performance is there, and the coverage here will be 25% of the yearly consumption, trying to get as close as possible to the 100% coverage in the summertime. And usually when you have sanitary hot water consumption in summer, and you do almost all of it, it brings you always to this 20 to 30% coverage. That's what you can expect covering with solar thermal for, let's say, a standard district heating network, and that's also the percentage of decarbonization you can bring if your network is today only running fossil fuel. Another references. This one is in Germany. I wanted to put another references with the TVP technology just to show you that the more south you go in Europe. So here we are in Sontershausen in Germany. A little bit more irradiance than in the Netherlands. It's a solar field that is 4 megawatt peak with a storage tank of 1,000 cubic meter. This time the TVP, the production, the heat production is about 630 kilowatt hours per square meter per year. So you see that basically the heat production is directly proportional to the irradiance. It will be also proportional and independent on the temperature. The return temperature in this case is a bit lower than the one in the Netherlands, so that brings a bit more efficiency as well. And there is the frost protection here is without glycol. This is a must in Germany. They for environmental reasons, you cannot run an installation with glycol. So basically, we have a frost protection systems that recirculate the heat and take a little bit of heat from the storage when you have a risk of freezing. Everything is automated. By the way, it's something I haven't said, but a solar thermal field is capex intensive, of course, because like all solar solutions, you have the installation costs at the beginning, but then on an OPEX, on a maintenance and operation standpoint, it's really low OPEX because you have almost no maintenance except maintaining the thermal equipment up to date. The panel doesn't require any cleaning because in Europe we have the chance to have natural rains often enough to clean the panels. So no need, really low maintenance, and the fact that the panel is insulated with high vacuum makes it also easier to propose a frost protection system without the glycol. Just because the fluid that is in the panel will not be impacted by the negative temperature, outside temperature of at location. So you see here I've put a screenshot of the control system of this installation. So you have here the panels that are represented. You see the return temperature in blue around 62 degrees Celsius, producing about 90 degrees Celsius at the time we were making the picture, and it goes into a tank or bypass this tank directly to the network with two heat exchangers here. And the tank at that time was fully charged because you can see the temperature at the top of the tank is about 96.5 degrees Celsius, and the bottom is 63. So corresponds to the temperature on the network side that are about 60 degrees Celsius return and 94.4 for the supply. So that's typically the way an installation will work, and also it gives you also an idea of the PNID, the schematic basically of this kind of installations. That's it for these references. And then two more references also that you can find. A good source of information is this IEA Task 55. I've just extracted two other references. I will not comment them in details, but this one is one in Serbia. It's a pretty small one. You see 906 square meters, and was done with another technology with flat plate. It has also some short-term storage, and it is in combination with a gas boiler for the city of Pančevo in Serbia. And another one in Denmark, 14.5 megawatt. Again, flat plate technology, short-term storage, combined with wood chip and a natural gas boiler for this utility district heating in Grena in Denmark. And some also hints about the costs and the OPEX, the O&M costs of such type of installation. Usually, and this will depend on different parameters, but the main parameters are the irradiance at site, are the temperature of the network, are the technology you're gonna select, and the incentives available. You can expect a cost of it, let's say between 40 euros per megawatt hours to maybe 80 euros per megawatt hour. And that will really depend on the different combination of parameters between sunlight, temperature network, technology selected, and subsidies available in the country. Recently, another example, Poland became really dynamic from one day to another on solar thermal installation for district heating networks, thanks to a subsidy program they just put in place last year that subsidized 50% of the capex. So even if Poland is a low irradiance country, you can find the right technology and the right also size of project that thanks to the subsidy will become really attractive for the district heating operators. About subsidies, so you have a regulatory framework in EU. There are some subsidies available. So basically, the framework is in place. And you also have the European Bank for Reconstruction and Development, the EBRD, that is also contributing a lot and willing to support a lot this development of solar thermal projects for district heating network. The Pristina project in Kosovo and the Novi Sad in Serbia, the two projects I was mentioning before, have both been subsidized, incentivized by the EBRD, and not only on the execution of the project, but also from the starting point of the project from the studies. So the studies can be entirely subsidized by EBRD. So of course, if you are interested in developing a project, you can both go either to the Solar Heat Europe Association or directly to the EBRD to get more information about how to start and how to get these financial supports that frankly are much welcome, because you will anyway go and enter into a process that will take at least 2 years to make some feasibility studies, and that has a cost, but has no guarantee of success. So having some support, financial support, to actually take a step and make this feasibility study and start investigating solar thermal is a big chance, and can be used widely and fairly easily also to obtain and to start. I'm arriving to the end of my presentation. So conclusion: solar heat plants are based on a simple, well proven and reliable technology. So we have seen this morning that there are different technologies for different temperatures, all running autonomously, existing for many years, and also backed by certification that de-risk the technology and gives a good hint about how reliable and how predictable the energy output will be in the lifetime of the system. There are many references around Europe. Most of them can be visited. Us at TVP Solar, we are organizing a lot of visits here in Geneva for one of our first plant connected to a district heating network that was commissioned in 2020. We also organizing trips to Germany and trips to the Netherlands to see different size, different scales of projects. So do not hesitate as well to contact us or contact Solar Heat Europe if you are interested to visit. These references are here to also to share the experience and show that it makes a lot of sense to use to harvest the sun for heating. These technologies are all long lifetime technologies, more than 20 years. Sometimes with a loss of performance, sometimes not. Like typically the vacuum collectors, if you guarantee the vacuum, basically you have no deterioration over time of the performance. So that brings you an amount of heat that will be produced over the lifetime, and it's really easy to predict what will be your cost of heat and the energy output in the first year, but also 20 years later. Low heat price, I already give these figures, between 40 to 80 euros per megawatt hour can be expected, depending on the location and the project. Low maintenance costs, less than 1% of the capex yearly. And finally, easy to couple with other energy sources. It's anyway needed to couple with other energy sources. Also with different heat technologies, either the storage technology, either if they are for short-term or for mid-term storage. And of course, a high reduction of CO2 emissions. We've seen it. Something I didn't say, but the efficiency of a solar collector is 2 to 3 times more than the efficiency of a PV of a photovoltaic panels. So for the same amount of space used, you're going to produce about 2 to 3 times more energy, and that's something that is really interesting, because when you have a piece of land where next to it there is a district heating network, a pipe of a district heating network passing by, you really have to think about, do I install photovoltaic to generate electricity, or do I install a solar thermal collector to bring heat to this network? And with a really different efficiency and different use, land use and density of energy produced by these land use. And last point, the fact that also it's produced in Europe. So by installing solar thermal, you will contribute to the European economy and industrialization. Thank you very much for your attention. I hope I was not too long in my presentation, and I'm here to answer your questions with pleasure. Thank you.
Thank you, Florian. I think the length was perfect, and indeed we heard really interesting facts about solar thermal. So I hope there is going to be a few questions. Tamás jelentkezett előbb. Minden esetre bátorítanám a közönséget, hogy tegyenek fel kérdéseket, hogyha felmerült esetleg valakinek.
The first question is always the hardest, and then it's easy. So maybe I have a question for the audience. Does anybody present today have already investigated or at least think about integrating solar thermal into your district heating network?
Tehát a kérdés, hogy valaki vizsgálta-e már a lehetőségét napenergia hasznosításnak, vagy gondolkozott-e rajta esetleg a jelenlévők közül?
Mi gondolkodtunk rajta, hogy ha beindul a pályázat, akkor tudom talán előbbre lépni.
They were thinking about it. Once there's gonna be an opportunity, they will start it for sure. It's the question of financing.
Okay. So today, David, the subsidy scheme is not yet implemented in Hungary, right? It's in process, but you don't have a specific incentive program for solar thermal for district heating, right?
Not for solar thermal, we have for renewable energies, but we are waiting for the tenders to come alive and be able to apply for the tenders. They've been already promoted for the utilization of renewable energies in district heating, but the tenders are not yet available.
Okay, understood.
So if there are no more questions, I'm pretty sure Florent would be open for any other questions in the future.
Yes. So you have my contact details on the screen. Feel free to, of course, recontact me by email or by phone. TVP Solar is a manufacturer of solar thermal collector, but we are also developing ourselves some projects from A to Z. So we are capable to do some opportunity study or like what we call discovery study. You know, with few data from your side, mainly the consumption, the temperature, and the available space. We can already do for you for free an opportunity study that will give you more insight about how solar thermal can help your district heating network, either to decarbonize, but also price-wise, because we've seen it. Solar thermal energy can be competitive against fossil fuel. So it's also a way to make your cost of it more competitive by using solar thermal. So again, feel free to contact me. I will do a study with pleasure for your district heating network that will be custom for your district heating network, so that you have a 360 overview of how solar thermal can help you.
No, thank you for the opportunity. I think this is a great opportunity for anyone thinking in investing into solar thermal. Úgyhogy, hogyha jelenleg nincs több kérdés, akkor nagyon szépen köszönjük a figyelmet és az előadónak az előadást. Úgy gondolom, ez egy kiváló lehetőség azok számára, akik tervezik napenergia hasznosítását, tehát nyugodtan keressék fel Florent a jövőben, és ő segít, illetve a cégük segít egy kutatás elvégzésében, vagy egy adott esetet megvizsgálni, hogy lehet napenergiát hasznosítani. So Florent, thank you again for the presentation, and I wish you to have a nice day.
Thank you, David, for the invitation again. Thank you, everybody, for your participation, and hope to see you or talk to you soon.
Yeah, likewise.
Bye.
Bye. Köszönjük szépen a figyelmet, viszont látásra.